Hello children, welcome to channel Sube. Children, today I am going to discuss question number 45 from the MCQ part of 2021 Physics New Syllabus paper. A solid conducting sphere of radius 2r contains a cavity of radius r inside it as shown in the figure. The sphere carries a net charge of positive q, another point charge, that means there is a positive q charge on the surface, outer surface of this sphere. Another point charge of positive q is placed at the center of the sphere. So there is another charge here without touching the metal at the center. So using an insulate stage, that positive q charge can be placed without touching the metal surface, inside surface, is placed at the center of the sphere. Which of the following graphs best represents the variation of the electric field intensity capital E with a radial distance r from the center of the sphere? So there are 5 graphs, the variation of field intensity capital E with the distance simple r. So children, let us try to solve this problem. So let us draw a diagram same as this one given. So this one is the sphere, so it has 2 times r radius, the outer shell, outer surface. So it is metal or conducting material. So radius, inner radius is r, outer radius is 2 times r. Outer radius 2 times r. So they say there is a charge inside, positive q. So let us for a moment forget this positive q charge that is on the outside surface. Let us take only this one first, because otherwise it is difficult to understand. So children, the force lines, you know, from a positive charge, force lines are going away like this, directed to the outside of the positive charge. So force lines are like this. That means there is no force lines in the material, because that is a conductor, that is a metal. So we know in the lesson we learn that there are no force lines in a metal. There are no force lines in a metal. So like this, there are no force lines here. So therefore the field intensity E is 0. It is 0. So therefore when we come out from the inside center, from the center, we should have a 0 capital E field intensity region when we pass this material. So that they have shown it here in the graph, so it is correct, from r to 2r, because this metal medium begins when the distance is r and finish when the distance is 2r. So in between this r and 2r there is this metal or conducting material. So in between those r and 2r, so therefore the electric field intensity should be 0. So in every graphs they have shown it correctly. So using that knowledge we can't select the answer, therefore, because every graph has it. So now let us check the field intensity, the magnitude of field intensity at this place. At this place, just inside the inner surface, just inside the inner surface. So distance is capital R, we can take as capital R the distance, because very close to this inner surface we take a point. So at this point the field intensity can be calculated using Coulomb's law. because this one is a point charge, this one is a point charge. So using Coulomb law, 1 upon 4 pi epsilon naught, the charge is q, divided by the distance r squared. So this is the equation. Using this equation we can find out the magnitude of the field strength, field intensity, capital E, just inside the inner hollow, this hollow sphere, inner sphere. So let us simplify it. We don't have any data, just q only. They have given q and r we know, so these we have substituted to this equation. So let us take this term, the total term, as E naught. Let us say this value after simplifying, it is E naught. That is the unit we are going to use, because now we are going to after a while we are going to calculate this outer surface, the intensity of outer surface also. Then we get these terms, the same terms we get. So therefore for convenience, let us consider that this magnitude is equal to E naught. So the E naught, let us now begin to plot the graph at the same time. Without using the graphs they have given, we are going to plot our own graph. So this one is the field intensity. So there must be somewhere this E naught value. So let us suppose this level is the E naught, that is specific value E naught. So let us divide this E naught into 4 like this. We divide into 2 and again we divide, now quarter, then here 3/4. So now we can label E naught, quarter E naught, half E naught, like this, then 3/4 of E naught. So like this, the values of y-axis is like this. So let us now, this one is the distance from the center, r. So let us now mark the capital R, the radius inside, the radius of inside sphere, and this one 2 times r, the radius of the outer sphere. So r and 2r. Now let us mark this value E naught, when the distance is capital R, so the value is of field intensity is E naught. So this one and this E naught, we get a point like this because of this simple q, positive simple q inside the inner sphere. So now let us calculate the outer surface, just away from the outer surface. The distance is very small, negligible. So again let us calculate the field intensity E using this same equation, 4 pi epsilon naught q divided by, so q is this q, still this q, because only this q we have forgotten that outer surface q for a moment. So q divided by, now the distance is 2r, so total 2r squared of that. So 2 times 2 is 4 times r squared we get. So this field intensity is generated by this simple same simple q. So we first assume that this term is E naught. So let us mark it. This one is E naught. So we have 1/4, 1 upon 4 additionally. So we can write 1 over 4, the quarter E naught. This one E naught, quarter E naught. Now the field intensity just away from the outside from the outer surface, just close to the outer sphere, is quarter E naught. So therefore, when the distance is 2 times r, quarter E naught is the field intensity. So we can mark this point. So our graph should be like this. Graph should be like this because of the inner charge, the charge inside the sphere. So it is like this. The graph is roughly like this because of this charge only alone. Because of this charge alone, the field intensity varies like this. But actually we have another charge. Let us now take that into our account. So now let us mark it here, positive q. But that positive q is not staying at this place, only at this place. It is spreads like this. It is not a single charge. So the positive q charge is spreads along this surface like this. Even though it is a single letter, the charge is behaving like this. So positive q is like this, spreaded along this surface. So there are force lines like this, but they don't affect inside. Why that they don't affect inside? Because actually there are force lines to inside like this, and also this at the same time from this opposite charge has a force line like this. So they are opposite to each other, therefore they cancel each other everywhere. That happens. So here also there is a force line towards inside. So by this one there is a force line towards inside. So these both cancel each other. Therefore there are no force lines are generated by this outer surface charge to the inside area. So therefore what we calculated already, so this one is not affected by the outer surface charge. So that is correct, that this part is correct. But the outer part, this part is not correct. Because we have to take that outer surface charge into account. So now let us calculate. Therefore this one is not valid because of this outer surface charge. So now let us calculate the outer surface real field intensity. Let us take a point here. So at this point we are going to calculate field intensity. E equals there is a theory. When we are going to calculate this, we should know that there is a theory. If we calculate anything out of a sphere at a place like this, we can consider the charge. All the charges are concentrated at the center. So then we can take this q to the center like this, this charge to the center when we calculate anything outside of a sphere. So now there are two charges at the center, positive q, the black one and blue one. So therefore E equals 1 over 4 pi epsilon naught. Now there are inside there are two charges, 2q, divided by the distance is 2 times r squared. The whole thing should be squared, then 2 times 2 is 4, r times r is r squared. So like this. So we discussed at the beginning 1 over 4 pi epsilon naught q divided by r squared we take as E naught. So this one. So let us mark that part 1 over 4 pi epsilon naught. Then before that we have to simplify this. 2 cancel, then here 2. Then that one 1 over 4 pi epsilon naught, then q divided by r squared is, that is E naught. So now we have half this 2, this blue 2, half times E naught. That is the real field intensity due to these both charges. So now let us mark it. This is the real one. This one is not valid, I said, that is why I made it dash lines. So 2 half times E naught. So from the y-axis half times E naught is this one. This point is the field intensity. Now actually we can see outer area of the sphere very close to the outer surface. So from there, furthermore from there when we go beyond, the intensity should decrease like this according to 1 over r squared. So now the final graph is like this. I draw it using red color. Final graph is like this. It comes like this with a small curve, and leaves like this with a small curve, and this region has 0 field intensity. So this is the final graph we receive after doing these calculations. So now we have to choose something equal to this one. So this one is wrong because the levels are same. This the second level should be half of the first level. So let us draw a line like this. So this one is E naught. This one is half E naught. Twice. We can see roughly from the graph half E naught. So the second part should start with a value half E naught. So this one is correct, therefore this graph is correct because this graph shows roughly half E naught. Half, this one is 1, so this one half. So this one is the correct answer. Here this one is wrong. So children, you might think that since there is a positive charge here, the field intensity should be something greater, stronger here, because there is a q charge. So at very close to the q charge, the field intensity must be higher. But that is not like that, because if you think about this q as a single charge, that is true, but this q is not a single charge. Number of charges are there are number of charges, so they distribute like this. So the field intensity decreases, weakened. The field intensity is not such strong. Therefore, if it is a one charge, then what you think is correct. At this point, the field intensity must be something higher, because very close to the positive charge we are taking. But it is not true, because the charges are distributed on this big surface. So the surface is a big one, so therefore the strength is very low. So it is exactly equal as if we kept it here. positive q, if we kept it here, so there is a certain field intensity here. So that is equal to the field intensity when we place this positive charge on the surface, because it is distributed and get weakened. So it is equal to the same field intensity if we kept it at the center. So that you have to take into account when you try this problem. So this one is wrong because it is true this area is 0, this area is 0, but the field intensity from the center itself has decided to reach the value 0 here. It is look like that. It has decreased, it is field intensity targeting this 0 value at the beginning itself. So like this it decreases in this graph, according to this graph, at the beginning itself. So that doesn't happen like that. The inside field intensity is higher, so suddenly when we come to enter this region, it decreases suddenly like this. So it is not gradually decreasing. So therefore this one is wrong. This one is wrong. As if this E knows that it is going to be 0 here when we reach this place, it is going to be 0. Therefore let us decrease rapidly to reach that 0 value. So like that it doesn't happen. It doesn't happen like that. It is as if like that. This graph is like that. So that one is wrong. So children, this one is correct if the outer charge is not there, because this one roughly quarter E naught. We get quarter E naught when only the inside charge is there. So here like this, when only the inside charge is there, this region, we get quarter. So but there is another outer charge, so therefore this one is wrong. If only the center charge is there, this one is correct, but the problem is not like that. So this one we get for gravitational fields, this type of a graph. If there is a planet, so it has mass here inside, solid, soil. So if it is filled with soil like this, so the gravitational field intensity we write as simple G, not T. So that change from the center to outside like this, linearly it changes. So therefore it doesn't match with this. This is electrostatics. So this is not a gravitational field. Therefore it is wrong. It is correct for gravitational fields, and also it is correct for insulated sphere, charged insulated sphere like this. If there is a insulated material and there are charges inside it evenly like this, so we can't charge it after making the insulated ball. We have to make it by mixing insulated material dust with a charged dust, mixing them, and finally we have to make the ball. So if we made it like this, the field intensity from the center to outside is to the surface is changing like this. So if it is an insulated charged sphere, so then it is correct. But our problem is a hollow sphere, not something like this, not an insulated one. It is a conducting sphere, so therefore this graph is wrong. So finally we decide that this graph is correct. So I explained why this one is wrong. Even though this charge appeared to be a strong one, because we see this positive q, and here also positive q. So if we see a positive q like this, we imagine that very closer to that letter, the field intensity is very stronger. But I said, even though it is appearing here like this, but it is not like that. It is distributed everywhere. So therefore the field intensity gets weakened. It is distributed like this. Some charges are very far away like this, so distributed. So therefore here the electric field intensity is not as much as higher as we imagine. So it is equal to the electric field intensity as if it placed here at the center. It is same to that. So therefore this one is wrong. This one is wrong therefore. So the correct one is this one. So now children, I have changed the question so that it will be a target question for you. So this target question now you have to try. Target question number 1. So as previously, do it on your own. Try this without watching my answer. Pause the video, read the question. A solid conducting sphere of radius 2 times r contains a cavity of radius r inside it as shown in the figure. The sphere carries a net charge of positive 3q. Now another point, full stop here. Another point charge of positive q is placed at the center of the sphere. Which of the following graphs best represents the variation of the electric field intensity capital E with the radial distance r from the center of the sphere? So I am going to solve it. So let us forget as previously the outer positive 3q charge. So the field lines, force lines, spread like this, not inside the metal. So now, as in the previous question, let us forget the outer discharge, the charge of the outer surface. Without that, only taking the charge inside the sphere, this one. Let us calculate the inside field intensity E. So as previously, we get it 1 over 4 pi epsilon naught q divided by r squared. So we took it as E naught. So this time also we are taking it as E naught. So so now let us calculate. Now let us calculate the electric field intensity at this point, a distance from the center, capital R distance, that means the surface of the inner sphere. So 1 over 4 pi epsilon naught. So we have not taken into account this one. Let us take it later as previously. Only this charge, only this charge in the at the center we are taking. So the charge is Q, only this one is at the center. So distance is now R, then R is squared. So we take this one as E naught. So at a place away from the center, capital R distance, the electric field intensity is E naught. So we mark this point at a distance capital R. The field strength is C naught. Then this point just out of the outer surface. So field intensity is equal 1 over 4 pi epsilon naught. Still we have this charge, only this charge, Q divided by the distance is now 2 times R, then the square value of the total thing, then 4R is squared. Then we get this thing as, this term as E naught. Therefore we have now 1 over 4, this 4 is still there, E naught. This is the field intensity out of the surface, just because this single charge at the center. So quarter E naught. So this is the point, here is the point. So the graph should be like this. If we consider only the center charge, the graph is like this. But actually now we take this one. So there is another positive Q charge, So I mark it using green color on the surface like this. It is on the surface distributed, but it acts as if it were at the center. It acts as it were at the center. Even though it is on the surface, the behaviors are as if it were at the center, because it is distributed. So it is weakened, it is not stronger, even though this symbol shows us, make us feel that at this place the field intensity is very stronger, but it is not like that, because it is at the center. Even though it is at the surface, it behaves as if it is at the center. So positive 3Q. So if it is, so that means we can move it like this positive 3. So I can delete all these positive marks and take this 3Q to the center. So there is a principle in our lesson, that we can consider for any calculations out of the sphere. We can place the charge at the center and use the Coulomb's law. So now we are calculating the real electric field due to both charges. So this one is 1 over 4 pi epsilon naught. Then how many charges? 3Q plus Q. Totally inside there are 4Q, 3Q plus Q. Then divide by 2 times R squared, that means 4 times R squared. 2 times 2 means, so 2R, the total thing should be squared. Then we get this. So this one cancel. Then we get 1 over 4 pi epsilon naught Q divided by R squared. So that is equal to what? E naught. The previous one, E naught. That is equal to E naught. So the real intensity after 2r distance is E naught, this one here. This one is the point. So beyond that, the strength intensity decreases according to 1 over r squared. According to 1 over r squared, that means a shape like this. So beyond that, the shape is like this. So now this part is not valid, because this part is valid only if this center charge is alone there, but there are two charges. So now the final field intensity is this green line. So now we can draw the equivalent final one. So like this, go to 0, stay 0, and rise suddenly to this value, and coming like this and leaving like this. So this is the final one. So these points are at the same level, you can see now at the same level. In this question, these points are at the same level. So at the same level, this one is the correct one. Here the same level. The first one is the correct answer for this question. So if your answer is correct, you can be happy. If you are wrong, you have to learn this way. You should do it the way I showed you, then you will be able to do it in future. So children, let us go to the next one. So I think you can understand this. If we are calculating anything, we can move the charges on the surface to the center. So that is a principle. Children, here is our next target question number 2. Let us solve this. Let us mean you have to solve it on your own. First, a solid conducting sphere of radius 2r contains a cavity of radius r inside it, as shown in the figure. The sphere carries a net charge of positive 4q, positive 4q this time. Another point charge of positive q is placed at the center of the sphere. Which of the following graphs best represents the variation of the electric field intensity E with radial distance r from the center of the sphere? Now on your own, try to do this alone without watching my video. Pause the video and try it. You have to just follow the way I explained previously. Now I am going to start. Let us take a copy of this. So first what we do, without this external charge, let us keep it aside. Without that, let us get the graph for this inside positive q. So previously we did it, therefore I don't explain much. We take the field intensity here E equals 1 over 4 pi epsilon naught. The charge is Q. Here to this point, the distance is capital R. We are considering this point very close to the inner surface. So the distance is R from the center. So R is squared here in the equation. R is squared is there. So we said that this one we take as E naught. So we mark it on the graph paper, on the grid, E naught, this one. When the distance is R, the intensity is E naught. So this point we get. So after that what we do? We try to find the intensity, field intensity outside of the outer surface, but very close to that. So here E is 1 over 4 pi epsilon naught. Still we are taking the intensity due to this charge, due to this charge. So the charge is Q. Now the distance is 2R. Then total 2R, we have to get the square value. Therefore 2 times 2 is 4. R is squared. So we cover the E naught value. So this one is E naught. This one is E naught. You can see Q divided by R squared. Without this 4. So we can now write 1 over 4 times E naught. The whole other terms are E naught, equal to E naught. So this is the field intensity. Just close to the outer surface. So that is the distance is 2R from the center. So quarter E naught means quarter is, this one is quarter. So at 2R, so this one is the point. So we get the graph due to only the charge at the center, that is positive Q. This is the charge, this is the graph we get according to that. So like this. If that charge were alone in the center, if it were alone in the center. So but actually there is another charge, this one. So now we are going to consider this one, because we first plot the graph for the for this center Q, because we can then respectively to that we can find out the next peak. So now we take this one to where it was, but the charges on the surface, so this one is like this, positive charge is distributed like this on the surface. So we can consider in such a case we can consider the charge is at the center. We can consider, even though the charge is at the surface, but we can consider the charge is at the center. So that is a principle only for outside calculations. So we are now calculating outside the sphere, outside of the sphere. So therefore we can place this charge at the center. Then we can use the Coulomb law. So like this we can place at the center. Now let us calculate here, just above the, just out of this outer surface. the point is this one. So E equals 1 over 4 pi epsilon naught. Then what is the total charge? 4q plus q, 5q. 4q plus q is 5q. Divide by the distance is 2r. The distance is 2r because it is here 2r. Very close to this outer surface. We don't consider this, it is negligible. Then 2r means when we take the square value, 2 times 2 is 4, then r times r is r squared. So this is the equation. So we have to then convert into how many E naught. How many E naught are there? So let us cover 1 over 4 pi epsilon naught q divided by r squared. This part is E naught. Then we can write 5 divided by 4 times E naught. 5 divided by 4 times E naught. So this one is the actual intensity with all these charges, with both the charges. So that means E equals 1 quarter. 5 divided by 4 means 1, then remaining quarter, E naught, 1 quarter. 1 quarter means already here 1 E naught is here. Quarter means we have to, this one is quarter, we have to measure this length and place it here and then draw another line to represent this quarter, 1 quarter, 1 and quarter. So here the value is 1 and quarter E naught. 1 and quarter E naught. So that is the real actual field intensity with both the charges just 2r distance, at 2r distance. 2r distance is this one. So both the charges make together this value. So after that, beyond that, now from here when we go further out to the infinity, this strength, this intensity is decreasing according to 1 over r squared. 1 over r squared. So that means the curve like this. So therefore just we have to now draw a curve like this, a curve. So now we have finished, our calculation is finished. So finally what we have gotten, so this one goes to 0 like this because the metal is there, conductor. So here like this. So from the beginning it's like this, and this part is like this. This one is the final. So now this one is not valid because we have considered both the charges. This one also not here. This one also not valid because we have to consider this metallic medium. So our answer is the peak is above this first peak. First there is a bend, first bend. So our peak is above that. So look at the answers. Here the two peaks are equal. Here the second peak is below the first one. Here this one matches with the answer. It is quarter times above. So that is the answer for this question. This is the answer for this question. So children, I think this is not difficult. If you followed the steps properly without getting confused, you can do it. So children, what happened to your answer? Is it correct? If it is correct, you are a genius one. You are a genius one. You know actually electrostatics. So you can get a, suppose, A pass. Keep up, keep up. So let us go to the next one. So if you are wrong, so you have to do more exercises like this, again and again do the same things, even same things. Again you do this first one, again you do first one, and again you do second one. Then you will be having some thing in your head. The things should be in your head, then you can do it. So that is the secret. So let us go to the other one. Children, here is our third target question. You have to read it and try this alone without watching my video. A solid conducting sphere of radius 2r contains a cavity of radius r inside it as shown in the figure. The sphere carries a net charge of minus q. Another point charge of positive q is placed at the center of the sphere. Which of the following graphs best represents the variation of the electric field intensity E with the radial distance r from the center of the sphere? Now pause the video and begin. So children, now I am going to try this one. So let us keep this external charges by the side. Without that, let us consider only the charge at the center only, alone that. So as previously, what we have to do, we have to get the field intensity at this point. So I am not going to take much time to do that. So we know now it is equal to 1/4 pi epsilon naught q divided by r squared. So we considered it as, we assumed it as E naught, So this one is the E. So we plot the, so now let us plot that point on the graph paper like this. And again what we did, we took the outside field strength, so that was 1/4 pi epsilon naught. Inside charge is q, the distance is 2r, so 4r squared here we get. So substituting E naught, we get quarter E naught. So that also we plot here at distance 2r, quarter E naught is the point. So we can plot this graph like this for the q charge alone at the center. But actually there is another charge, it is this one, minus q, but it is distributed like this on the surface everywhere, like this it is distributed. So we can place all these minus charge at the center of the sphere for any calculations out of this sphere. So now we are going to calculate the field strength, field intensity at this outer point out of this surface. So therefore we can assume that this charge is not on the surface. We can assume that as it is at this inside, at the center. So like that we can assume actually it is on the surface, but we can assume because the result we get is same, even though we keep it at the center or we keep it on the surface, the result is same. So we can use only the Coulomb theory now to calculate this one. So E equals 1 over 4 pi epsilon naught. So what is the charge now? Plus q minus q, then 0. But the total charge, the algebraic sum of the charge is 0 now. Therefore we get here 0 divided by 4r squared. Therefore what we get is 0. Therefore the point we have to mark is at the distance 2r using purple color, here 2r. Then this one is not valid, only this part is valid, because now we have considered the both charges. So the final graph is like this. Since there is a metallic medium, that means this conducting medium, so further it goes along the x-axis, that means 0. So the answer should be this one, 0 after r. After r it is 0. This one is the answer. That can be described another way also. Another way means you can take this to the place where it was, and you can mark the minus charge like this. Or before that I have to mark the previous field given by this one. So it is like this, you remember, it is like this, the field lines like this out of the positive charge. Now this due to this negative charge that is equal to q, so I mark only, since there are 1, 2, 3, 4, 5 force lines for this positive q, since the magnitudes are equal, I mark only 1, 2, 3, 4, 5 negative charges. So each this charge has a force line towards the sphere, like this. The color is invisible, therefore I use this one. So like this, negative, 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 negative. So now q is over. So force line towards the sphere, since it is negative, force line towards the sphere, force line towards the sphere, force line towards the sphere, force line towards the sphere. So these are cancel each other. This cancel because the direction is opposite. So now, are there any force lines out of this sphere? No, there are no force lines, because the force lines created by this positive charge is cancelled by the force lines created by this negative charge. They are opposite to each other. Therefore, there are no force lines outside. So that is the result. So therefore there is no any field intensity outside of the sphere, outer sphere. So this one is the answer. Therefore, if you have done successfully, if your answer is correct, you can be happy. You have a head that can use for logic. You have a head, actually, brain in the head. Okay, so if you couldn't get the correct answer, so you have to do again and again more exercises like this. So let us going to now wind up the video. I think you understood, so you can face the next exam. If you are lucky, you will get a problem like this. So children, I think you are happy. Let us conclude what we have done. First we did this original question number 45 MCQ1. Then what we did this target question 1 and also target question 2, target question 3. So we did today 3 target questions and also the original A-level question, MCQ question. So I think you are happy. Children, if you are happy, you have to do what? You have to subscribe my channel if you haven't still subscribed it. Don't subscribe twice. If you haven't still subscribed, please subscribe my channel. And also what you have to do, share my link with among your friends, and also press the bell icon so that you can get the message as soon as I uploaded the video, and also press the thumb up icon. That means you can give me a like. When I see those likes, I get encouraged. So children, thanks for watching my videos, and also thanks for those who subscribe my channel. And then tomorrow at 6 o'clock, let's see you again. So goodbye.